Assalamu alaikum wa rahmatullahi wa barakatuh. This is to welcome you to the next edition of our online class. You are welcome back from the Eid celebration. Today, inshallah, we are going to discuss the chemistry of Earth and space, the last topic in the curriculum. The basic information. The chemistry of Earth and space deals with the knowledge of the chemical reactions that take place on Earth and other parts of the solar system, including the Sun. We all know that the Sun and the 9 planets make up what we call the solar system. This aspect of knowledge is usually referred to as astrochemistry, which is the study of abundance and reactions of molecules in the universe, as well as their interactions with radiation. And this discipline is where astronomy and chemistry overlap. For those of you who are geography students, you would have come across many things that we'll be discussing today. Yet, the chemical aspects or the chemical view of those things would have to be emphasized. The Sun. Like you're already aware, the Sun is a very big ball of glowing solar gases, which is about 300,000 times bigger than the Earth. So if we know the size of the Earth in 300,000 places is the size of the Sun. And the glowing gases that we have in the Sun, they are at the portion of the Sun that we call photosphere, which emits both heat and light, as we can feel it on Earth. The heat that we feel from the Sun and the light that it radiates are from the photosphere portion of the Sun. The chemistry of the Sun, or otherwise the chemical composition of the Sun. The Sun, like we have said, is made up of gases, and the most abundant gas is hydrogen. The second most abundant gas is helium. There are other compounds that are also in the Sun, which also exist in gaseous form. Among them is carbon. We know carbon at room temperature is solid, but because of the extreme heat in the Sun, it exists in gaseous form. We also have nitrogen, we have oxygen, we have fluorine, we have phosphorus, we have calcium, we have silicon, we have sodium, we have iron. All these components we mentioned are in small quantities. The only ones that are in high quantity are hydrogen and helium. The surface of the Sun has a temperature of 6,000 degrees Celsius. But as we go deeper into the Sun, the temperature increases to such an extent that at the center of the Sun, the temperature is 30 million degrees Celsius. And how does this heat get generated? The heat in the Sun is generated as a result of series of chemical reactions, which are nuclear reaction. The type of nuclear reaction involved is fusion reaction. The fusion between hydrogen atoms to form deuterium with the admission of neutrino, hydrogen atom with mass number of 1, proton number of 1, mass number of 1, proton number of 1, combine together to form deuterium, emitting electron, that is beta particle in the process, together with neutrino. Deuterium will fuse again with another hydrogen atom. You know, deuterium is Fv hydrogen, making up containing mass number of 2 and atomic number of 1. When deuterium fuses with another atom of hydrogen, it would form helium nucleus plus gamma ray. Helium will fuse with another hydrogen to form, and the helium that is formed there is having atomic number of 3. So atomic mass of 3, atomic number of 1, atomic number of 2. So 2 helium having atomic mass of 3, atomic number of 2 will fuse with 1 atom of hydrogen to form the normal helium nucleus having atomic number of 4, atomic mass of 4, atomic number of 2, and together with gamma ray. So these are the reactions that take place in the sun, and it is fusion reaction. In other words, the heat emitted by the sun is generated by fusion reaction of hydrogen. You have the normal equations in your notes. Now the solar system, that is the sun in relation to the other planet, to the planets, which are the other components of the solar system. Like you must have been aware from your knowledge of geography, we have nine planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. In that order, that is in increasing order of closeness, of distance from the sun. That is, Mercury is the closest planet to the sun, followed by Venus, followed by Earth, and the most distant planet from the sun is Pluto. Even though recent researches is trying to prove that Pluto is not one of the planets, that it is rather moon or satellite of Neptune, but it is still being classified as a planet on its own. Until that research is concluded, Pluto is still being regarded as a planet. The first 4 planets are the hottest. That is Mercury, Venus, Earth, and Mars. These are the hottest planets, and they are collectively referred to as terrestrial planets. Terrestrial planets. Now looking at them one after the other. Mercury, it is the closest planet to the sun, and it is the hottest. It is made up of minerals that are embedded in rocks. So that is, in Mercury we have rocks. These rocks contain minerals. That is, the rocks are rich in minerals. And it's also made up of its own atmosphere that contains hydrogen, helium, and neon. These are the gases that make up the atmosphere of Mercury. The next planet is Venus, which is usually referred to as the Earth's twin. The planet referred to as the Earth's twin is Venus, and it is the second closest planet to the Sun after Mercury. Its atmosphere is composed of carbon dioxide mainly, which is 96% of the atmosphere. Then we also have nitrogen of about 4%. Even though some other gases are present in trace quantities, like sulfur oxide, argon, oxygen, carbon dioxide, hydrogen chloride, hydrogen fluoride, and water vapor. Next to Venus is its twin, because they too much resemble in terms of size and temperature, even though Venus is a bit hotter than Earth. The Earth is the third planet. It's also made up of rocks, which are rich in minerals. It's made up of water. In fact, we are going to look at Earth especially, because we are dealing with chemistry of Earth and space. But we are talking about space first. Then we are going to talk more about Earth. So the Earth is the third planet, and it is the only planet that supports life. Even though researchers are considering whether Venus or Mars can also support life. But Venus is too hot to support life. While Mars is also close to Earth in terms of temperature, but at least it is a little bit colder than the Earth. But currently, the only planet that supports life is Earth. And it is the only planet that has abundance of water and oxygen. And that is why it even supports life. So that's why we have many plants and animals on Earth. Its atmosphere is made up of 78% nitrogen, about 21% oxygen. Then we have traces of noble gases and carbon dioxide. After the Earth is Mars. Mars is also made up of rocks that are rich in minerals. It is dry, and compared to the Earth, like I've said, it is cold. Its atmosphere is made up of carbon dioxide, argon mainly, but we also have water that is in trace amounts, carbon dioxide, and oxygen very little amounts. Jupiter is the largest planet, and maybe this is why some people will say that no, Jupiter can change it. It is the largest planet, and its surface is very cold. You can see it's a little bit distant from the sun. Its atmosphere contains hydrogen with little amount of methane and ammonia. Then we have Saturn. Saturn is the second largest planet after Jupiter. It has a very cold surface. You can see it is so distant from the sun. And its atmosphere contains mainly hydrogen and helium. But there are traces of methane and ammonia. We have also Uranus after Saturn. Uranus is very cold, colder than Saturn that we just discussed. It has atmosphere of hydrogen and helium, but there are traces of ammonia and methane, like we said for Saturn. Then the next one is Neptune. Neptune is very cold, very cold. As we move away from the sun, then the farther we move away from the sun, the colder the planet. So it is very cold, and we are having an atmosphere of hydrogen and helium. But the methane that is present in Neptune is frozen, since it is extremely cold planet. Then we have Pluto. Pluto, like I told you, is very small, and today some researchers say it is even not a planet. It is the smallest planet and the coldest, being the farthest from the sun. Its atmosphere is made up of only solid methane. You can see the difference. Only solid methane is present in Pluto. But in Neptune, we have hydrogen and helium, but the methane there is solid, frozen. So there's a difference. If we are talking about a planet that is made up of only solid methane, we'll say Pluto. If you are talking about a planet that contains frozen or solid methane with hydrogen and helium, then we're talking about Neptune. Next, let's now look at the Earth as a body. The Earth has a satellite which is called Moon. The Moon is also made up of rocks, just like the Earth. And the Earth that is found, the rocks that are found in the Moon are similar to the rocks that are found on Earth, but their chemical compositions are different. There's no water, there's no air in the Moon. The Earth can be divided into three main parts. We have the atmosphere, we have the lithosphere, we have the hydrosphere. The part of the Earth that is composed of air is called atmosphere, and it has 5 different layers. The troposphere, which is the lowest part of the Earth, where weather is confined, and that is where we live. Up, as we leave the atmosphere, as we leave the troposphere, we get to the stratosphere. That is the upper layer of the atmosphere, which is very cold. There's a popular saying, the higher you go, the colder it becomes. The stratosphere is colder than the Earth. It is at the stratosphere that we have the ozone layer. At the stratosphere, there's neither water nor dust, but we have ozone. We have talked about ozone in our SS2 chemistry, which is an allotrope of oxygen, O3, that is planted there by the Almighty in order to absorb the ultraviolet rays of the sun, so that the amount of ultraviolet rays that get to our own Earth, that gets to the atmosphere, is not too much so as to cause harm to living things. But we know what our activities do to ozone layer, depleting it. So the ozone layer is at the stratosphere. After the ozone layer, if you go up, we get to the mesosphere, which is even colder than the stratosphere. After the mesosphere, we get to the ionosphere, which is also called thermosphere. Then after the thermosphere, we get to the exosphere. The exosphere is composed of hydrogen, and that is the last layer of the Earth. The second part of the Earth is hydrosphere, and that is the portion of the Earth that is made up of water. This hydrosphere makes up about 71% of the Earth's surface. That is, if we divide the whole Earth into 10 places, 7 parts of such, or a little more than 7 parts of such, is water. And the water contains mostly dissolved minerals, and please take note of this, the most abundant dissolved mineral in our water is sodium chloride. Sodium chloride is the most abundant mineral in hydrosphere, that is the Earth's water. Even though there are other minerals that are dissolved, like we have other chlorides. Magnesium chloride is there, calcium chloride is there, and some other chlorides like that. We also have potassium tetrasulfate 6, magnesium tetrasulfate 6, calcium tetrasulfate 6, dissolved in the hydrosphere. Then also dissolved in water of the Earth is oxygen, nitrogen, and carbon dioxide. Each of these has its own purpose. Dissolved oxygen serves as a means by which aquatic life can carry out respiration. Dissolved carbon dioxide serves the purpose of photosynthesis for aquatic plants, and then nitrogen serves as source of protein for aquatic plants as well. Then we have lithosphere. Lithosphere is the part of the Earth that is made of solid rocks and soil. Lithosphere is also divided into three parts. We have the outermost part, which is called the Earth crust. We have the middle part, which is called the Earth mantle. Then we have the innermost part, which is called the core, the Earth core. There are about 100 elements in the lithosphere. All the elements that we are talking about, there are about 100. The other elements can be manufactured by nuclear reactions. Then take note of this. The most abundant element in the Earth crust is oxygen. The most abundant element in the Earth crust is oxygen. The second most abundant element in the Earth crust is silicon, which is usually present in the Earth crust as silica. That is silicon dioxide, and that is sand. That's what we call sand. So if we are talking about the most abundant elements in the Earth crust, we talk about oxygen. Please take notes of this. This does not contradict what you earlier know, that the most abundant metal in the Earth crust is aluminium. This statement tells us that oxygen is more abundant than aluminium. Silicon is more abundant than aluminium. But because the two of them are non-metals, if you are talking about metal that is most abundant, we say aluminium. But if you are talking about elements generally that are present in the Earth crust, the one that is most abundant is oxygen. And the second most abundant element is silicon, which is present in the form of silica or sand, and that is SiO2. Then at the core and mantle, we have ores of metals. So where the part of lithosphere where ores of metals can be extracted are core and mantle. So you have to dig down into the middle part or to the innermost part before you can get us out of the lithosphere. Also part of the surface are the stars. If you go up, you see the stars. Stars are self-luminous objects that shine due to radiations that are emitted from within themselves as a result of fusion reactions that are going on inside them. Stars, within stars, there are nuclear fusion reactions that take place within them. As a result of this, they emit light. So the light that they emit in form of radiation is what illuminates the planetary bodies. In fact, the sun is the largest star. It's also a star. There are stars, according to astronomists, stars have been classified into different groups as a result of their sizes, ages, colors, luminosities, temperatures, and chemical compositions. Those that have the same chemical composition but with different temperature and pressure are called first generation stars. They are also called the main sequence. When the main sequence grow older, they contract and form red giants. Red giants are those ones that will contract again to form white dwarfs. For your information, the sun is a typical second generation star. When we have collection of stars, so many stars coming together, we will say that they have formed galaxy. A galaxy is a combination of many stars. So clusters of stars are called galaxy. And for the Earth, if you are on Earth, the stars that are visible from the Earth are called Milky Way, and there are about 100 billion stars for the Earth. 100 billion stars. Other bodies that make up the solar system are asteroids, comets, and meteors. Asteroids are called minor planets, and they are rocky worlds revolving around the sun. Just like the planets revolve around the sun, we also have asteroids revolving around the sun. But why don't we call asteroids planets? Because they are too small to be called planets. So even though some asteroids are bigger than the others, those ones that are bigger among them are called planetoids. That is small planets. In the case of comets, comets are icy-like solar system bodies that pass close to the sun. They get warmed in the process and release gases. And the process by which they release gases are called outgassing. Sometimes if you see comets in the sky or up, we will see that they will be projecting like bodies that have tail. Those are comets. We also have meteoroids. Meteoroids are small rocky or metallic body in outer space. They resemble asteroids, but they are smaller than asteroids in size. So if you are talking about rocky substances that revolve around the sun, so we are talking about asteroids. We are talking about small solar bodies, system bodies that moves close to the sun and release gases as a result of the heat they absorb from the sun. Then we'll be talking about comets. We are talking about small rocky or metallic bodies in the outer space. Then they are called meteors. So that will take us to the end of our discussion about the outer space as well as the earth. From this little knowledge of yours, you will realize that there are so many bodies, there are so many spaces that are known to man, yet there are still so many bodies or spaces in the outer space that are not yet known to man. So when Allah in the Quran says Rabbul Alamin, that is the Lord of the worlds, you know what that means? There is not only our earth in existence. Even though we say that most of those planets and other bodies, other planetary bodies, do not support life. That is to the extent of our knowledge. That is life according to our own definition. There are lives that we cannot perceive, because those bodies couldn't have been created for fun. The Almighty Allah grant us understanding and bless our knowledge. We will discuss more as we soon start meeting physically. Assalamu alaikum wa rahmatullahi wa barakatuh.